Take an electric torch. Fix a black paper with a slit at the center to the glass. Fix a white sheet of paper on a drawing board with the help of drawing pins. Place a strip of plain mirror upright at one end of the paper on the board. Switch on the torch and place it on the board in such a way that the beam of light falls on the mirror at an inclined direction. This beam of light is called incident ray. After striking the mirror, the beam of light is reflected in another direction. This reflected beam of light is called reflected ray. Draw lines showing the position of the plane mirror, the incident ray and the reflected ray on the paper. Let M1, M2 be the line representing the mirror and point O be the point of incidence, that is, the point where the incident ray strikes and the reflected ray bounces back. Let PO be the incident ray and OQ be the reflected ray. Remove the mirror and torch. Draw a line OM, making an angle of 90 degrees with the mirror M1, M2 at point O. This line is known as the normal to the reflecting surface. The angle between the normal and the incident ray is called the angle of incidence and is represented by the letter I. The angle between the normal and the reflected ray is known as the angle of reflection and is denoted by the letter R. Angle POM is the angle of incidence and angle MOQ is the angle of reflection. Find the measurements of angles POM and MOQ. Do you think that the angle of incidence and the angle of reflection are equal? Let us check this out. When you repeat the experiment for different angles of incidence, you will find that the angle of incidence is always equal to the angle of reflection. While performing this experiment, you will notice that the incident ray, the reflected ray, and the normal are all in the plane of the paper. Thus, the experiment helps to infer the laws of reflection. Let us state the laws of reflection. The laws of reflection are: the incident ray, the reflected ray, and the normal are all in the same plane. The incident ray and the reflected ray are on the opposite sides of the normal. The angle of incidence is always equal to the angle of reflection. That is, angle I is equal to angle R. Reflection of light from a plane mirror. Let us verify the laws of reflection by performing an activity using a plane mirror as the reflecting surface. Activity: fix a white sheet of paper on a drawing board with the help of drawing pins. Place a strip of plain mirror upright at one end of the paper on the board. Mark the position of the mirror as M1 and M2. Fix a pin on the paper. Mark the position of the pin as P. Mark 3 distant points, A, B, and C, behind the pin. Now, try to see the image of the pin P through point A. Mark the point where the image is seen as point D. Draw the line of sight. Similarly, see the image of the pin through points B and C and draw the lines of sight as BE and CF respectively. Remove the mirror and join M1, M2 using a scale which represents the mirror. Extend each line of sight, that is, line AD, BE and CF beyond the line M1, M2. These lines intersect at a point, say O. What can you infer about the point O? This is the actual point where the image of the pin was formed. Hence, we can conclude that the image is formed at a single point. We can consider this point to be the point from where all the reflected rays of light appear to have diverged. Now, draw perpendicular line segments from point D, E and F. Join PD, PE and PF. Denote the angles on either sides of the three perpendicular lines as Q, R, S, T, U and V respectively. On measuring angle Q, angle R, angle S, angle T, angle U and angle V, you will find that angle Q is equal to angle R, angle S is equal to angle T, and angle U is equal to angle V. Note that each of these angles are pairs of angle of incidence and angle of reflection. This proves that when a ray of light is incident on a highly polished surface, the angle of incidence is equal to the angle of reflection. This proves the laws of reflection of light.